So let's take a look at this worksheet. First and foremost, the directions, right? Solve the problems below, show your work, use correct units. A table of specific heats can be found on page 476 in your text. That's sort of an important thing because you're going to need some specific heats to solve these problems, okay? Number one, we'll actually kind of answer number one as we go through and do some other things. Number two, change in temperature. Always, okay, remember the symbol for that is delta T. Remember that change is final minus initial. Okay, so final minus initial, ending minus starting. Okay, doesn't matter. Yeah, if you subtract in the wrong direction, you'll end up with a positive when you should have got a negative, or a negative when you got a positive. If it cools down, that's a negative change. If it heats up, that's a positive change. Alright, number three, suppose one substance has a specific heat of 0.235 and another has a specific heat of 1.38 joules per gram degree Celsius. If equal masses of these things are heated, which one's temperature will change faster and why? Well, remember what specific heat means. Okay? Specific heat tells you how easy something's temperature changes or how much energy is required to change its temperature. So if there's 0.235 joules per gram degree Celsius, that means it takes 0.235 joules to raise its temperature by 1 degree for every gram. The 1.38 takes 1.38 joules for every gram. So that means this 1.38, takes about 6 times as much energy to get it to change. So it's a bigger number. So it takes more energy to make it change. The littler number is going to take less energy to get it to change. So the 0.235 joules per gram degree Celsius will change faster, and that's because less energy is required. Alright, let's take a look at the next problem here. Okay, it says, how much heat is needed to raise the temperature of 3 kilograms of water by 60 degrees Celsius? Well, always keep in mind that when we're talking these heat problems, we're always going to use this same formula, Q equals mc delta T. Okay? And the trick to solving any of these problems is to recognize these numbers, these given things in the question. Okay? So if I'm looking for Q, how much heat is Q, that's my question mark. I don't know that one. 3 kilograms of water. Grams measure mass. So that's telling me I have 3 kilograms. Now I need to be very, very careful with that unit. Kilograms are not grams. Okay, so it's got to go to 3,000 grams. C is equal to what? Well, C is specific heat. And it's telling me it's water. So I go to that table on page 476, I look at the specific heat of water, it's 4.18 joules per gram degree Celsius. And then finally, delta T, that's the change in temperature. It says right here, we're raising the temperature by 60 degrees. Okay? So 60 degrees Celsius is my delta T. I'm going to put all this information up into the formula. And so Q is what I don't know, so I just rewrite Q. M is 3,000 grams, so 3,000. C is 4.18. And delta T is 60 degrees, so multiply them all together. And after I do that, I'll have my answer. But you got to remember to include units. So 3,000 times 4.18 times 60 equals 752,400 what? Well, Q is a measure of heat, which is a measure of transfer of thermal energy, and energy is measured in joules. So my final answer is right there. You need to make sure you show these steps. You need to make sure you show me this equation, and you need to make sure you show me your work. Okay? That's how you get your points. If you make a mistake in your multiplication, but you set this thing up correctly, you're going to make it. Okay? If you don't show me your work, I don't have anything to grade. Okay? Number 5 here. Suppose 300 joules of heat are added to 500 grams of iron. How much will its temperature change? So this is a little bit different, but it's still a Q equals mc delta T problem. Okay? You just got to get your variables identified. So Q, it says 300 joules of heat. Well, there I know. I've got my heat, 300, are added to 500 grams of iron. Oh good, there's a mass, 500 grams. How much will its temperature change? Delta T is what I want to know, and iron tells me that its C is 0.449. Okay, I got to go to the table in the book to get that. Alright, so now I can just put everything into my equation and see how to solve this. So Q is 300 equals M is 500, C is 0.449, and delta T is what I'm trying to find. Okay? If I don't know something, I write it there so I don't forget what I'm doing. Okay? First thing I want to do is I'm going to go ahead and multiply these two terms together. So I take 500 times 0.449 and I get 224.5. So I rewrite my equation. 300 equals 224.5 delta T. Now I can divide both sides by 224.5, right? Because they're multiplied together, so to get them apart, you divide, you undo the multiplication. That term cancels and I'm left with 300 divided by 224.5, which equals 1.33. Okay? Remember, we need units on that, so I'm going to rewrite that over here. 1.33, it's a change in temperature. Temperature is measured in degrees Celsius. There's my final answer. Okay? It's pretty straightforward, but pay attention to the order of operations. Number 6, suppose 100 joules of heat are added to silver and it increases in temperature by 30 degrees Celsius. How much silver was heated? Well, again, we're using this formula because we're messing with heat. Q equals MC delta T. How much silver was heated? So I know I'm going to be looking for mass. What information do I know for sure? It says 100 joules. How much silver was heated? So I'm looking for mass. It says its temperature increased by 30 degrees, so I got a 30 degrees Celsius temperature change. And C, again, I'm going to have to look in the book, and the specific heat of silver is 0.235 joules per gram degrees Celsius. Okay? So now I'm looking up at my equation, and I've got to just put all that information into the equation and solve for what I don't know, and I don't know mass. So I'm going to say 100 for Q equals M for M, since I don't know it. C is 0.235 and delta T is 30 degrees. Okay? Again, I'm going to go ahead, I'm going to multiply the 0.235 and the 30 together, and when I do that, 7.05. Okay? So I'm going to rewrite my equation. 100 equals M times 7.05, and then I've got to divide both sides by 7.05, and when I do that, that cancels and I'm just left with M all by itself. So 100 divided by 7.05 equals 14.18 M. Okay, equals M. Remember, I need my units. We're measuring mass. Mass is measured in grams, so 14.18 grams. Okay, showed my work. I set it up correctly, and so I should be good to go. Getting close to the end here. Number 7, suppose 2,000 joules of heat is added to 120 grams of water at 25 degrees Celsius. What is its final temperature? Okay, so again, Q equals MC delta T. 2,000 joules. 120 grams. Water. C equals 4.18 for water, right? And then what is its final temperature? Okay, this one's a little bit tricky because it doesn't ask for a temperature change, it asks for a final temperature. But we can figure this out, right? Because it tells us an initial temperature. Well, let's go through, use the equation. We're looking for delta T, and then we're going to have to go one step further. So if we take Q, 2,000, equals M, 120, times C, 4.18, times delta T, I'm going to multiply the 120 times the 4.18, which is 501.6, so 2000 equals 501.6 times delta t, it's still there, and then I'm going to go ahead and divide both sides by 501.6. I end up with 3.99 equals delta t. Okay, that's degrees Celsius. Okay, but this is not the answer to the question. Okay, we have to go one step further. Okay, 3.99 is delta t. Okay, that tells me the temperature changed by 25 degrees, or not by 25, by 3.99 degrees. If it started at 25 and it changed 3.99, now we know it's up here at 28.99 degrees Celsius. There's my final answer. Okay, so don't stop early. We got to get up to there. Number 8. Suppose 3.4 kilograms of rock cools from 60 degrees Celsius to 25 degrees Celsius. If 221,344 joules of heat are released, what is the specific heat of the rock? We need to be careful on this one. We're still using the same equation, but we need to pay special attention to what's actually happening. Okay? So when I come over here to pull out Q, M, C, and delta T, I got to be careful. 3.4 kilograms of rock. So that's my mass. Remember, kilograms becomes grams. We move the decimal 3 places right. So this is 3,400 grams. Okay? Cools from 60 to 25. Final minus initial, 25 minus 60 is negative 35. Okay? If 221,344 joules of heat are released, that's telling you it lost 221,344 joules. That correlates with my change in temperature. If my change in temperature is negative, my heat needs to be negative because I'm losing heat. And I'm supposed to find C, the specific heat of this rock. So I'm going to put in everything I know. Negative 221,344 equals 3400 times C times negative 35. Okay? From this stage, you can either decide to divide or you can multiply and then divide. I'm going to go ahead and multiply these two things together first, so I get negative 221,344 equals 119,000 negative times C. Then I'm going to divide both sides by negative 119,000, divide by negative 119,000, and now I've got two negatives over here, so they cancel each other out, and I'm left with 1.86 equals C. So C equals 1.86 joules per gram degrees Celsius. And we're good to go. Specific heat of 0.13 joules per gram degrees Celsius. Excellent. If 250 grams of gold increases in temperature from 12 to 62, how much heat does it absorb? Okay, so again, Q equals MC delta T. And Q, M, C, delta T. Let's see what we know. Gold has a specific heat of 0.13, so there's our C, 0.13 joules per gram degree Celsius. 250 grams of gold, there's our mass, 250. Increases in temperature from 12 to 62. Okay, remember it's final minus initial, so 62 minus 12 is 50 degrees. How much heat, so how much Q, right, do we absorb? Well, this is a straightforward problem. 250 times 0.13 times 50 degrees, and we'll be done. So 1,625 joules. Okay, there's our final answer. Taking care of it.